Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see an important application of op-amp, which is integrator and differentiator. So in all the two mathematical operations, integration and differentiation, so an op-amp can be used to perform these two operations. An integrator is an electronic circuit that produces an output that is the integration of the applied input. An op-amp based integrator produces an output which is an integral of the input voltage applied to its inverting terminal. So in the circuit shown, the non-inverting terminal of the input op-amp is connected to the ground. That means 0 volts is applied to the non-inverting input terminal. According to the virtual short concept, the voltage at the inverting input terminal of the op-amp will be equal to the voltage present at its non-inverting input terminal. So, the voltage at the inverting input terminal of the op-amp will be 0 volts. So now let us write the nodal equation at the inverting input terminal, which is 0 minus Vi divided by R plus C into, we have 0 minus V naught divided by dt is equal to 0. So we'll get minus Vi by R is equal to C into dV naught by dt. dV naught by dt is equal to Vi by RC with a negative sign. So dV naught is equal to minus Vi by RC into dt. So when we integrate the equation on both the sides, we'll be getting integral of dV naught is equal to integral of minus Vi by RC into dt, which implies V naught is equal to minus 1 by RC into integral of Vi into dt. So when RC is equal to 1, we'll get V naught is equal to minus integral of Vi into dt. So the op-amp based integrator circuit will produce an output which is the integral of the input voltage Vi when the magnitude of the impedances of the resistor and the capacitor are reciprocal to each other. So we note that the output voltage V0 is having a negative sign, which indicates that there exists 180 degrees phase shift difference between the input and the output. So this is an op-amp integrator waveform. An input signal, when it is given as a square wave, you will be getting a triangular wave as the output when we perform integration operation. So next one is op-amp differentiator. So a differentiator is an electronic circuit that produces an output equal to the first derivative of its input. An op-amp based differentiator produces an output which is equal to the differential of the input voltage that is applied to the inverting terminal. So the op-amp based differentiator circuit is shown here, where the non-inverting input terminal of the op-amp is connected to the ground. That means that 0 volts is applied to the non-inverting input terminal. According to the virtual short concept, the voltage at the inverting input terminal of the op-amp will also be equal to 0, that is the voltage at the non-inverting input terminal. So the op-amp based differentiator circuit will we proceeded as follows. So you'll be writing the nodal equation of the inverting input terminal. So we'll be getting C into d of 0 minus Vi by dt plus 0 minus V naught by R is equal to 0, which implies minus C into dVi by dt is equal to V naught by R. From this, V naught is equal to minus RC into dVi by dt. When RC is equal to 1, we'll be getting V naught is equal to minus dVi by dt. So then the op-amp based differentiator circuit, the output produced is the differential of the input voltage when the magnitudes of the impedances of the resistor and the capacitor are reciprocal to each other. Note that the output voltage V naught is having a negative sign, which indicates that there exists a 180 degrees phase difference between the input and the output. So this is a differentiator waveform. So when you give input signal as a square wave, you'll be getting spikes as the output. When you give a triangular wave, the differentiation will produce a rectangular wave, and the sine wave will produce a cos wave. So the applications of these are differentiating amplifiers are most commonly designed to operate a triangular and rectangular signals. Differentiators also find applications as wave shaping circuits to detect high frequency components in the input signal. Integrator circuits are mostly used in analog computers, analog to digital converters, and wave shaping circuits. So hope you understood what is integrator and differentiator. Let us take a few assessment questions. The expression for the integration frequency is, as you know, it is 1 by CR. The expression for the differentiator time constant is, it is CR. So for integration, you get the expression as 1 by RC, and for differentiation, you get the expression as RC. The phase in the integrator and differentiator circuits are, yes, the answer is plus 90 degrees in the integrator and minus 90 degrees in the differentiator. Thank you for watching this video.